Hello everyone, Par on this side. So today what's new? Today new is synthesis, turning code into a chip parts. How is this possible? So let's discuss. What's the synthesis? Building a chip blueprint is a synthesis. Synthesis is like a turning a car scratch into a blueprint for the real parts. Okay, so let's suppose you have a toy car, okay, and you have sketch of that toy car, and after that you would see what will be the real parts of that car. So like that car sketch is the RTL design, okay, written in a very long HDL, describe what chip does, what is the functioning, what will be the function beyond that. Okay, right now we have to transform that RTL to a gates. So this implementation, like we have to go with the synthesis, and on which behalf we will go on synthesis, like we have some gates and codes, and we are going to turn around them in switches, in gates. That is a hardware implementation of the software functional programming. So what it does, it is synthesis of that code. Like you have a functional view of anything, like that as I discussed with you, there is a car, and this car have some sketches that you got, okay, but you don't know about what are the real parts of that car. So right now, on behalf of VHDL, okay, hardware description language, HDL, we can define like what will be the parts, gates, switches, these are the parts, okay. Like right now we have concern, why does logic synthesis is important? Efficient design, ensure minimal power consumption, optimal performance, reduced area, automation, handle million of elements. Synthesis can handle million of elements systematically for large circuits. So that's why it is emphasized. Okay, right now we have concerned manufacturing read lines. Okay, prepare the design for backend stages by converting hardware language to gate by adhering to technical constraints. Okay, so how synthesis works step by step. So right now I would give you a brief overview about that. So let me discuss with you. Okay, so first of all, what we do, we have the RTL code. Understand? Right now we are going to understanding the design. The synthesis tool the start with RTL code written in Verilog. Okay, it's synthesized to code to understand components such as register, combinational logic, FSM, finite machine, like what it is. The functional behave we have elaborated in a design, and right now we have to check like what it is in real. Like we have given a if else statement, using if we are performing a operation, it will happen. So if both will true, that very time it will happen. So it is work of the AND gate. Like if both condition are true, it is the AND gate. If one condition is true, one condition is not true, so that very time it will be OR gate. So like this I have given you a small example, so we can discuss about much more. So right now after this we have another concern is unpackaging the design, means elaboration. The RTL is expanded into full hierarchical structure, resolving modules, instances, connection, analogy, assembling a LEGO set based on instruction. Okay, now we have to come on next technology mapping, assigning resources. Abstract logic is mapped into specific standard cells. Okay, in the technology library, for example, we have to abstract the logic is mapping into specific standard cell in the technology library. Now, for example, logical operation like AND may be mapped to NAND gates from the library. Analogy, choosing material to construct bricks, woods, these are the things. Okay, right now we have to come on our next step. It is a logical optimization, refining the design. Optimization, what is the mean of optimize? Like we have to refine the design after being a view with the assigned view. So okay, let's come on that. Operation remove inefficiencies and meet constraint. Technique include Boolean specific Boolean specification, reducing redundant gates in logic, gate sizing, adjusting gate size for better performance and power efficiency, analogy streamline building plan to estimate unnecessary elements. So right now we have to come on our next step. It is a netlist generation, finalizing the plan. Okay, the step turn into a gate level netlist, a blueprint for the chip hardware analogy, finalized construction plan showing every beam, brick and the nail. Okay, thank you.